All right, everybody, welcome to the Building Performance Podcast. This is a live podcast, so if you guys are interested in sitting and paying attention and asking some questions later, you're more than welcome to do so. On this podcast panel, we have Bob Toner from Avx, we got Brent Lemert from HIC Micro, and Aaron Bond from Yes Plumbing and Heating. So I'm going to give you guys a couple minutes to introduce yourselves. Bob, go ahead.
All right. Avx is an electronics manufacturer in Durham Region, Ontario, and we have a very revolutionary remote monitoring system that is designed for all types of HVAC, both residential and commercial. And it installs in about 15 minutes. It's dirt cheap, and it gathers all kinds of data and allows for both remote diagnostics, and it actually allows you to remotely test before you even dispatch somebody.
Very cool. Cool. Aaron.
Aaron Bond. I'm with Yes Plumbing and Heating.
Closer to the mic.
I'm with Yes Plumbing and Heating. We're an HVAC and plumbing contractor in Durham Region. Unlike Bob, our stuff is not cheap, but it's good. We specialize in large custom homes and net zero building.
Awesome. Brent.
Hello, my name is Brent Lamert, and I'm with HIC Micro. We make thermal imaging cameras, the core technology all the way through to handheld devices for technicians and professionals to be able to see the heat. But when you see heat, you can find air leaks, water leaks, missing insulation. You can see in-floor heating, hydronic lines beneath the tile or concrete, as well as electrical and mechanical problems. Our goal is to educate everyone that this technology is easy to use, small and affordable, and should be in every tool bag. So, thank you.
Correct. So thermal imagery has been one of these things that has been, and I just want to ask you this quickly because in the past, thermal imagery and cameras have been very expensive. Now they're getting more affordable for every technician to carry in their tool bag. So has that transition in pricing have you started to see more techs carrying, like the average tech carrying thermal cameras in their tool bag?
I am starting to see that trend. There's a long way to go on that.
Yeah.
Most of the people that I've spoken to at this show this morning already, they may be aware of the technology, but they haven't gotten to the point where they really tested it out for how it would impact their workflow to save them time and really add credibility for their end customer to be able to show them what's happening with their structure or with the systems.
Okay. So we'll get to more of that in a minute. So building performance has been something that I've been trying to learn more about in the last 6 months or so. And Brent was on my podcast talking about this. Bob was on my podcast talking about this to a certain extent. But I've been reading a book called Healthy Buildings, or listening to a book on my drives to and from work. And one of the things that I found interesting, this is a story from the book about a building that was having a dust issue. So what was happening, during the day there was no dust on the desks. And at nighttime, the HVAC system shut down for the building, and when the employees came back the next day, there was dust all over the desk, black dust, and nobody could figure out what it was from. And what they finally found was that when the HVAC system shut down, the building was not under a positive pressure anymore, and there was a subway station underneath the building. So what was happening is that subway dust was coming up through the infiltration of the building, right? And because the HVAC system was not pressurizing the building, this dust would come up and land on the desk. So they had to keep it running 24/7, even when people were not there, to seal up all the cracks, right? So I thought that was really interesting from a building performance standpoint. And Bob, I wanted to get your thoughts on that from a control standpoint. How could we maybe solve something like that utilizing controls?
Yeah, well, I think that if the simplest thing would be to have a multi-stage blower or a variable speed blower, and that when in the off hours, just have the controls dial it back to a minimal amount of air ventilation, just to create a minimal positive pressure in there. That would be the first thing that entered my mind, and that would be a very low-cost solution to something like that. Detecting it beforehand to save the hours and hours and hours of man hours trying to figure out what the problem is would be in the realm of smarter controls that have the ability to take in data from sensors and record it so that people can analyze it, on a PC before you start ripping apart walls and machinery. But generally speaking, I would think that a bit of software adjustments could go a long way in something like that.
Cool. So, Brent, from a thermal camera, thermal imagery standpoint, is that something that we could pick up with a thermal camera when the building system shuts off to see this infiltration coming through?
If there's a difference in temperature, there's a good chance that we would see that. And the way to amplify it and make it easier to find would be to combine the thermal imager with a blower door. And even on a large commercial building, you can use blower doors to be able to find those weak spots where there are leaks, to then know, is it death by 1,000 cuts, where it's going to be very hard to fix the leaks and you need to, say, have the solution that Bob was talking about with a fan? Or are there some places where we can be somewhat surgical in fixing those air infiltration leaks and solving the problem there, and probably saving quite a bit of energy over time too.
Cool, cool. So let's move on to hydronic heating. Aaron, you're involved in a lot of hydronic heating, and guys listening, if you guys check out Aaron on LinkedIn, Instagram, his installs are complete. They're a complete work of art. They really are. He takes so much time, professionalism, and puts a lot of quality into his installs. From a building performance standpoint, how is hydronics sort of changing the game these days?
Interesting. I'd say hydronics on its own is not changing the game. I would say that the integration of hydronics with other technologies is really where it's at right now, especially when we're talking about home performance. We recently did large net zero homes in Durham region. And before I'd done net zero homes, I really didn't comprehend the challenges that we were going to face. Things as simple as makeup air. You turn your kitchen exhaust fan on, and your house goes under negative pressure, and your house smokes out. We're talking about envelopes, and sealing these houses up. But where's the fresh air coming from? And then when that fresh air comes in, we have to produce it efficiently with very cold climates outside. So hydronics is a big part of that we can heat a slab, for instance. We can put in-floor heating in. We can do it at low temps, which means that we're doing it very efficiently. This show has some very interesting products that are going to help further increase efficiencies of homes right now. Some incredible air-to-water heat pumps that are available now. We're really on the cusp of it, though, in our market. We're starting to see those efficiencies where we can do air-to-water solutions from heat pumps. We can still offer gas furnaces to do those hydronic solutions. But at the end of the day, it's hybrid systems that we're seeing. It's not a boiler for this efficient home. It's this boiler integrated with heat pumps and there's so many moving parts. I feel like we really haven't perfected an all-in-one solution for efficient building now, and it's complicated stuff.
Mm-hmm. And before we got on here, your eyes were bugging out when Brent was talking about finding leaks under a floor or in a wall in a hydronic system with a thermal camera. Brent, do you want to talk about maybe how because that is a huge part of building performance is moisture and how to maintain the moisture levels at a certain point so we're not too high, we're not too low. And if we have a leak behind a wall or in a floor, that's going to cause some major issues. So how do we go about finding those with a thermal camera?
Yeah. So thanks for asking the question. I'll talk about leaks in general, and then I'll talk some maybe more towards hydronic systems specifically, because a leak could be from the roof or around a window. It could be from storm damage. It could be from an air handling unit and a condensate line that was blocked, right? So finding the source of the leak, the extent of the damage, with water you have evaporative cooling. So the area that's wet will be cooler, and it's very easy for a thermal camera to pick that up and be able to see it, even if it's in the insulation behind the drywall. And that's something for anyone at the show, come to our booth. We have a piece of drywall and a little test for people to be able to try it out and see for themselves what it looks like. With hydronic systems, if someone takes your beautiful hydronic installation, Aaron, and drills through a slab and nicks a pipe, oh, that's bad, right? Yeah. Especially if it's a beautiful tile on top of it. It starts to get expensive to think about destructive testing for where that leak is. And with the thermal camera, we can see where the tubes are when you're heating the system up, so that, well, hopefully someone uses a camera before they drill, right? If they nick one of those lines, or if a line gets kinked and blocked, you're going to not have as much heating in that part of the loop. And you'll be able to see that. If it's actually leaking out, you're going to have an area that's at a different temperature and looks very different than the rest of the heating coils, and be able to find it really fast.
Amazing. I'm sold, man.
Okay.
Yeah.
So that's awesome. And Bob, I'm going to bring this back to you. The word predictive maintenance, because you've shown me probably a few different ways we've predicted problems before they became major issues.
Yeah.
With the software and the hardware that Avx has to offer. And Aaron, being a contractor, this is predictive maintenance is something that you'd be interested in, because yeah, exactly. So can you maybe take us through a few examples of how your software and hardware in one has predicted some faults?
Yeah, sure. So first of all, the Avx system uses 4 very, very inexpensive and quick to install sensors. And but what we do is we correlate all the data coming from several points and overlay them over top of each other. And what that does is it paints a picture of what's going on inside the equipment. And for example, last year we had a home where one of our system fired off an alert, said there was a blower problem. We checked with the homeowner and they said, no, everything's fine. The house is nice and warm, and it was a minus 20 day in February. But when we looked at the data, we could see that the capacitor was failing on the blower. And we know when capacitors fail, they don't just fail, they're working one moment and fail the next moment. They go through a decaying period, a rapid decay that lasts several days. And we were able to detect that, dispatch a repairman, and swap out that capacitor before the homeowner even had a problem with their home. And likewise, just recently, last weekend, our system, overlaying the data once again, detected a dirty flame rod on a gas furnace, and was able to alert somebody. So once again, it prevents the house from losing temperature, going into a state of pending damage, frozen pipes or anything like that, where then you have to get thermal cameras in to look for all the damage behind the walls. We're able to detect a lot of these things and dispatch people before anything serious is going on.
Yeah, and to a contractor, that's huge, because if you get an alert on your phone that maybe in 3 or 4 days your customer's furnace, AC, whatever it is going to go down, and perhaps that's going to be at a very bad time, like Sunday afternoon when you're eating dinner. But if you can deal with that on a Thursday morning, for instance, that is something that would be very, very valuable to any contractor. Aaron?
That's exactly where my mind went with that. I'm thinking to myself, we get our bulk of calls when it hits minus 30. And a lot of those calls we could have done something about had we known a week in advance when it was actually failing. And you say, there's this decay over time, sometimes days or weeks. But we want to identify that early. And what that does, ultimately, it sounds like your software makes us more reliable as contractors, because when we get that influx of calls at minus 30, you're waiting.
Yeah, exactly. And the shortage of supply of qualified technicians is a worldwide problem. Nobody can get the people. And now with this type of technology, and with technologies like Brent's, you can now service more customers with the same number of techs, lowering your overhead, getting out there and doing that type of stuff. So using technology to advance your HVAC business is, I think, the way of the future.
And increasing accuracy for diagnostics. We can send more Novus techs to a job with clearer insight as to what the problem will be and have stronger guidance. That's amazing.
Exactly. And the other thing that we're seeing is you get guys that are, say, approaching my age, over 30. For those who can't, you get somebody who's, say, late 50s, early 60s, who still has, some years before retirement. But he or she has got an immense amount of knowledge in their head and experience. But they're getting tired of climbing ladders and hauling. They're just getting tired of being out there. But they've got so much value to add to a company. Wouldn't those people be much more useful if you have junior techs who really are quite green, but to have your experienced person looking at a PC and analyzing and saying, okay, young fella, when you get to this house, go look for that flame rod or go look for that capacitor, because I think that's what you're going to see. And that young fella is in and out, and he learns. Okay, they're in and out, they learn, and the company's more profitable because now they're getting good training for those young people. They're reducing the amount of time spent scratching their head in the basement that type of stuff. So.
You come run our service department. It sounds like you'd be great.
I'll just say one thing about, I don't know if it's, we were talking about things that we can detect. One of the things that we detected recently was somebody cleaning up their backyard. This was actually last summer. I shouldn't say recently, last summer. Cleaning up their backyard and not understanding what an outdoor air conditioning unit does. They started piling things on the unit as they were straightening out their backyard, and then go in for lunch or something. And our system detected it instantly because the liquid temperature starts to spike up, and sends out an alert, and instantly we're aware that there's a problem. And you're able to contact, the service guy was able to contact the homeowner and say, what happened? And they were able to, oh, yeah, we just put some stuff, get it off. And it actually saved a call. So,
Can you tell us what the 4 areas that you're sensing are?
yeah, we sense the supply air, the return air. Okay, and we supply, and the liquid pipe and the suction pipe right at the coil inside the house.
Amazing.
Okay, and those 4 things, and then we correlate them over all the thermostat sensors, the thermostat wires, and on top of that, we have data about outdoor air temperature, indoor air temperature, and all those things. We and that gives us a ton of information.
Yeah, so there's far more than 4 points of data.
There's
You're crossing
multiple
a lot.
a lot more points of data. We just happen to use 4 sensors to get that.
data.
And what's cool about that is you don't need an amp probe on the blower to know that the capacitor was failing.
Yeah,
that's what blew my mind.
Yeah, we do it with temperature sensors.
Yeah, when you see you see how the trend goes, and I wish we had a screen here to show everybody what you mean by that and how we can watch those trends.
Yeah, and a buildup of cred on the outdoor coils. You see it slowly over time. We have it's air conditioning season down in Phoenix right now, and so we have one particular installation in Phoenix that the dealer called us and they weren't sure what they were looking at because they're new to Avx, and I said, that looks like just a dirty coil. It wasn't a particular problem, but it was a buildup over time. And sure enough, it was a rooftop unit, flat roof residential.
Because you're seeing progressive performance.
You can see
issues.
progressive heat rise relative on the liquid liquid temperature relative to the outside air was growing. That differential or the approach was growing.
Maybe you should. Brent, I'm gonna ask you a question about blower doors in a minute. But Bob, maybe you should tell Aaron about how Avx works with boiler systems too.
Yeah. The boiler system works. It's the same principle, except the sensors are a little bit different. We have a supply and return pipe sensors.
Can you use multiple?
I'm sorry, say it again.
Can you use multiple? Can we do zones? Sense
that's coming down the
zones?
pipe. That's coming down the pipe. The initial,
one.
there's a commercial version coming.
Amazing.
And it has multiple, so you can have zoning, that type of thing, and see which zones are active, that type of thing. But it also, in the case of a boiler, because the burner operates independent of the thermostat. When you're maintaining, like if you have a triple acting boiler, you're maintaining a temperature, so that burner can fire independent of the thermostat. So we actually sense if it's a gas valve or an oil-fired unit, we can sense when it's firing. And then check the pumps and see whether the pumps are running based on delta T's.
Amazing.
Across the pipes and across certain zones.
Will it give you an actual readout of the delta T?
Yeah. Oh yeah.
Very cool.
I can't show the listeners, but I could show it to you on my phone. I can also do a remote test, like my house right now. Even though that's pretty cool. I could probably turn the heat on right now from my house and run a test, and we could see the supply, the return. If it was summertime, we could check the liquid and suction right from here from my phone.
Ooh, that's
Cool.
huge.
First time I ever did it, I was in Europe and testing a house in Hamilton, Ontario, and I did it across the ocean. And my engineer was on the other end. And the moment I pressed the button on my phone, he said, "Yeah, burner just fired."
Yeah, we would probably put that on every install. Just so we could identify if a zone is down, if a system's down, what it's operating at. That's incredible information to be able to get remotely. Right now, what I get is I set the thermostat, and it's not hot. Okay, all right.
So let's change it up a bit. I'm going to get Brent's take on this because this is becoming more of a thing these days, and you're going to like this too, Aaron. I don't know if you've ever been involved with any blower door testing, but blower door testing is becoming bigger these days. And I know you've worked with Sam Myers over at RetroTech a few times with blower doors and how you implement the thermal camera after you depressurize a home or pressurize a home to find the leaky spots, windows, doors, cracks in walls, whatever. So take us through maybe like a simplified blower door test and what we would do and how we'd use a thermal camera to find the infiltration within the building.
Now, so Aaron, just real quick, the question from Gary: have you been part of a blower test?
Oh yeah.
Okay.
Yeah, quite a few.
All right. And did you use that for then sizing a system or adjusting the equipment that you were going to put into that installation? Or
Not as much as we use it for performance of air leakage.
Okay.
We want to see air leakage in the house, and we're hitting those air changes per hour. But the blower test primarily for us is air changes, not for equipment sizing.
Okay. So with blower doors, they used to be something that was only for, say, weatherization kind of activities. And one of the things that Sam's explained to me is he's seeing it as part of an overall system design, because particularly in places where we have more air conditioning, like where I live on the coast of North Carolina, we have unlimited humidity, as well as we're usually running the air conditioning. And if we have air leaks in that structure, we're going to have humidity problems. And if our air conditioning system is oversized, where if anyone follows the normal calculations for system design, an air conditioner is going to be oversized,
Always.
right? So then you're going to short cycle and bring in even more humidity, right? So with a blower door, you're able to, in the construction or the remodel process, be able to start to identify the areas and quantify the amount of air leakage. With a blower door, there's two ways that you can see where the air is either moving into or out of that structure. One is with an artificial smoke gun. So just like what you would use, Bob, in your old rock and roll days, putting out the smoke fog on stage.
Yeah.
But then you see where that smoke goes to either exit or where it's coming in from and moves through the structure. If there's a temperature difference inside to outside of roughly 10 degrees C, I can now use my thermal camera to see exactly where those air leaks are to be able to address them specifically.
Let me ask you a question. So you were talking to Aaron about using a blower door to size based on the amount of infiltration you're getting.
Yeah.
Are you seeing contractors taking this information and fixing the infiltration versus sizing according to the infiltration? Like, what are you seeing more?
Depends on if it's new construction or if it's the replacement of an existing system that maybe is 30 years old, what you're trying to do. Traditionally, if you're replacing a 30-year-old boiler or furnace or heat pump, there's a lot of contractors that'll just say, okay, that unit was this size. I'm going to just put in a new one the exact same size. And what is starting to happen in the industry is using more diagnostic tools to say, from a performance standpoint, this is actually the size we need, and starting to look at the overall building envelope rather than just blinders on, I'm only going to look at my HVAC, mechanicals, electrical, and starting to look at that envelope and seeing if there's some things that need to be fixed from an insulation, air infiltration standpoint, and then sizing a system that's going to make the homeowner or the building occupant far more comfortable. And that's not only temperature, that's also humidity, right? Making sure the ventilation is there so that you've got good, fresh air. And at the same time, saving money on the overall system design and the energy used by that system. And it just takes doing a little bit of education on these new tools, like a blower door, like thermal cameras, like Avx, to be able to have the information to do something really great.
Yeah, we're seeing, I would, off the top of my head, about 75% of the houses that we monitor are oversized. Grossly oversized. And where you can see that even my own home, when we put it on my own home, and I have a 60,000 BTU furnace here in the Greater Toronto area, and I can see that at the most, on the worst day of the year, I need 25,000 BTUs, the coldest days in the winter. And so it's very clear to me when it comes time, I should be putting in a heat pump with maybe a bit of electrical backup or something like that the variable output. We just see it all over the place. Air conditioning way too big, delivering air that's actually, while it's chilled, like they're delivering air at say 60 degrees F, instead of delivering it at in the low 50s. Well, yes, that cools the house, but it doesn't reduce the humidity in the home, and of course that leads to asthma problems because of the run-on effect of higher humidity. Raises the RH in the home.
I have a point to that. I kind of noted it, and it's almost like you read my mind. Ventilating dehumidifiers. Have you guys have any experience with them? Ventilating dehumidifiers from a building performance standpoint. So if you've got like a leaky home and it's got a lot of infiltration, you can actually bring in fresh air, pressurize the home, right? So you're not bringing in the infiltration because you're pressurizing it, you're pushing out. But what they do at the same time is they dehumidify that air that's coming in. So it takes load off of the system, but at the same time pressurizing the home with fresh air. So you're getting your ventilation requirements, but you're also treating that air before it comes in.
How do you integrate that with, let's say, an HRV or ERV?
I don't know how you'd integrate it with that. I've seen that it's either HRV or ERV or a ventilating dehumidifier. It's not both.
Interesting. So our building codes right now kind of incorporate that you have to have an HRV or ERV.
Yeah.
We're talking about monitoring and sizing of equipment. This is when you find out in our market though, after it's been in. And if you own a company that monitors your heating and cooling equipment, then you know that it's oversized. But the average homeowner does not know.
That's right, yeah.
And embarrassingly, most trade people, most HVAC contractors don't know that it's oversized or undersized. They did exactly what Brent said. They go, oh, that one there is 100,000. I'll put another 100,000 in. And one of the advantages that we have that's on our side is that a lot of the equipment that the manufacturers are coming out with now are modulating. So they're capable of catering to smaller heating zones. They have inverter technology on air conditioners, so it can ramp down and ramp up.
Yeah.
And so that, I think, is a big part of the saving grace. But we need to change our mindset and how we do home assessments, because the root problem, I believe, is home comfort advisors. We're sending salespeople in to do an assessment on a house, and they're more focused on, are you going to buy my product? Versus assessing the home and its particular issues. No home's alike. Blower door tests. Brent has that's exactly what we should be doing on every assessment. Before we're recommending equipment, we should be doing blower door tests and heat load calculations. But the money's not there for it. Mm-hmm. The reason being is, you're going to have 3 or 4 contractors come out to your house and give you a quote on a heating and cooling system and spend 3-4 hours doing an assessment on your house. So the government comes out with incentives with like heat pumps, and they require a blower door test and stuff. But that should just be a standard in our industry, that before you can get quotes on mechanical equipment replacements, that we've done an assessment on the efficiency of the home.
Yeah. So just one counterpoint to that person that's coming in to assess the home and sell the job. Mm-hmm. If they had a handheld tool that fit in their pocket and cost what the amp probe that you talked about earlier in our discussion costs, what that tool costs. Mm-hmm. Say less than $500, and you could show the homeowner where they're missing insulation, where there's thermal bridging, where there's air leaks for them to fix, and tie that into how you're trying to make sure the system is right-sized for them, that they're not going to overpay for a system that's too large. Do you think, as a salesperson, I would win more jobs?
Incredible value that you have there.
At the same price point, without having to cut price. I'm selling it on value, and I'm setting up that relationship to then, if I've got sensors like Avx, where I'm going to do predictive service, I'm going to have that long-term service contract revenue with that customer. They're going to be raving fans.
How do you sell that, Brent? How do you go from I identified that you have too little insulation here, and this wall is leaking, and your home's inefficient. How do you carry that? You're a comfort advisor. How do you carry that to the sale and identify the size of the equipment that you need? To me, Brent, the transition there is, I've identified that there's some problems with your home, which you'll always identify. So your home's inefficient, but we don't know how inefficient. The next step here is that we do heat load calculations on your house to identify specifically what we need for the equipment sizing. That's the only transition there because it's
Yeah.
not mandatory. We know what happens when it's not mandatory. We'll just skip that step. And
Yeah.
and to me, it's a very important step for building science and sizing equipment properly and having comfortable homes. And so we do. You said 75% of systems are oversized. I was like, oh, that seems like a low number to me.
Well, I was being cautious.
Yeah,
I think.
there you go. All of them that I see are
Yeah.
oversized, air conditioning and heating, or the air conditioner's drastically undersized because somebody wanted to save a buck to put it in, and it's just murdering the thing and not keeping up.
Yep.
But this is a problem that's plagued our industry for forever. I mean, we're pulling out 80-year-old boilers that are 120,000 BTUs in a 1,000 square foot house.
Well, this is something that Gary and I touched on the podcast back before Christmas, and that was that there has to be a trust relationship between the service provider and the customer. And if that trust relationship isn't there, if people are just, 4 different contractors show up to quote, it's going to be based on price. But if there's a long-term relationship with that customer, if you're providing service in between the 15 years where they're replacing their equipment, then they're going to trust you to do the load calculations and spend that time.
Sure.
And make good choices for them.
I think, Bob, I would agree to some degree. I think that there's many ways to convey value over the other 3 bidders on a project, but I think we need to find innovative solutions to teach contractors to be able to convey value through doing proper assessments on buildings.
Yeah, correct. I totally agree with you. And you brought up heat pumps. We talked about heat pumps standing over there earlier, Aaron. How do you see the trend in your work and the electrification, the term we're using these days, into this transition? Are you seeing a big transition into heat pumps these days?
Huge. We can't keep up. And I think the manufacturers and the distributors are just simply not ready. Unfortunately, our government never prepared when they put incentives out. They don't consult with any one hand, doesn't talk to the other, but they put incentive program out for heat pumps this year. During a pandemic where we were already short on stock, and all of a sudden you couldn't get anything.
Yeah,
you can get nothing. So how do I see them impacting the future of our industry? I think that heat pumps are very, very quickly going to become the norm, and I think that if you're in this trade, if you're doing heating and cooling in our industry, you better very quickly get on board with hydronics and heat pumps, because I think it's the marriage of those hybrid systems that are going to be the solution. When you look at Victoria, BC, you can't install gas boilers or furnaces there anymore. They're banned. Electrification is here.
Yeah.
It's here.
Cool. Okay, so what we're going to do is I'm going to give you guys the last thought, and then we're going to see if Whitney has any questions for us. Okay, so Brent, last thought, building performance.
Wow.
If you want to break it down, or give us maybe your definition or your take, or what building performance means to you.
So building performance used to be something that was such a small little clique of people. And what I've seen over 25 years in thermal imaging is it's gone from that small clique to being part of the main conversation for a broad range of homeowners, contractors, architects. And that's wonderful to see. And my technology is part of just making those changes visible. Instead of in the data, being able to tell that story to a homeowner and show them the impact of the tools, techniques, systems in place to give them the comfort and performance that they want.
Very cool. Aaron, what do you think about that?
I think he's on point. Definitely as building science becomes more of a mainstream and has the spotlight on it, we're definitely starting to build to a higher standard. I have homeowners asking me now if they can build net zero, whereas as little as 2 or 3 years ago, most homeowners didn't understand what net zero was. Mm-hmm. But as we have the interest for it, and as we start to build to that standard, we're identifying problems. We're identifying challenges that we have, with makeup air and with the equipment that we're currently using. And so I'm excited to see a lot of the products that are coming to market right now, but I really believe that we're in our infancy, that we have to change the way that we're selling these systems, that we're, our overall comprehension of how these systems operate. I think we need a lot more education amongst contractors so that we can educate homeowners.
Yeah, education is key. And Bob, what I'll say to you is you talked about relationship earlier with the homeowner, if it's commercial, the building operator. these relationships are key to prolonged service with any industry that you're in, right?
Yep.
And having this relationship and having the trust and providing the education to the customer is so important. And you don't have education if you can't show them anything.
Yes.
So
Yeah.
what we've talked about here on this podcast is actual visual stuff we can show to a homeowner, a building operator, say, this is what's happening to your building. Here's the visuals.
Yeah.
Let's do something about it. Because at that point, if they deny it, it's on them. So what do you think about that? Last thoughts?
Well, I absolutely agree with that, 1,000%. And I think, the name of this show is, the mechanicals exposition. And we, in this industry, tends to think mechanically, things that you can touch and feel. But we, I was born in the middle of the last century, when nobody really gave a rip about building efficiency and that type of thing. But we now live in the 21st century, and we are a data-centric society now, and the mechanical trades have to become data-oriented. And so information, like you say, whether it's on a smartphone or on a camera or a PC, we have that data. So the whole industry has to start thinking about collecting and presenting data in such a way that we can make buildings efficient and smart and reduce the energy footprint and make people healthier. And the only way to do it is with information.
Yeah.
You have to shift to information.
Very cool. Very cool. So, Whitney, do you have any questions for us? I'll start there. The future is getting, as far as tool technology, this will be a podcast we're doing tomorrow, but the tool technology, like for instance, checking pressures of an HVAC system. We used to carry this big set of clunky gauges around. Now we have smart probes that are about this size and take less refrigerant out of the system when we apply them. And what happens with that is all the information gets sent to your phone. Mm-hmm. And now you can create reports, like PDF reports, and send it straight to the customer or yourself. If you want to do a startup report, you're no longer writing it on a piece of paper. All your information is captured, and you can save it to wherever you want, and it's very easily done. So the industry is sort of, as far as the tool technology goes, to me it seems to be shrinking in size and providing more information and data. I don't know what you guys think about that.
I call it smarter, faster. When we have that information available to younger technicians now, they get smarter faster. We're sitting in groups now and analyzing their last service call, whereas years ago that wasn't the case. They, as Gary said, put a set of gauges on and they're reading these analog gauges. They're causing more damage to the system. They have to identify the problems on their own, whereas now it's kind of a group effort at most mechanical companies where their service departments are getting access to far more information.
Cool.
Yeah, to me, the toolkit of the future is the smartphone. It's a more powerful computer than we used to put the men on the moon in the 1960s, and it has it has tons of sensors. It connects via Bluetooth. Just Bluetooth alone, Bluetooth low energy. We can plop sensors all over the place, and it can all show up on your phone and be extrapolated and presented in a way that just gets the job done quicker and lowering costs and making buildings better.
Brian, you want to weigh in on that?
I want to weigh in by asking this team a question.
Sure.
Because I'm an inch deep and a mile wide in the various industries where thermal imaging is used. But how much of that tool bag in the future is sensors built in to the system itself?
Yeah.
So you're never attaching gauges, but you're getting those pressures and temperatures in a way that's still accurate. And that way the data, whether it's on a smartphone or it's distributed, however it is to the technician, they're getting information for decisions so that they're showing up. They always have the right parts on hand.
Hold on.
They know
I think Brent's talking about working with Bob here to create better sensors to take my job from me.
I was just about to say that.
this.
We have to be careful how smart the equipment gets, because we could send any warm body out to swap a part once the unit diagnoses itself. And that's one of the points that a lot of techs are very scared of. They're scared of losing their jobs to smarter technology and smarter equipment that can do it for them.
So, is a really good tech simply someone that knows where to place the gauges? Or is a really good tech someone that knows what to do with the pressures?
Agreed.
And be able to, as we have more and more hybrid systems, they're far more complex than what we used to have,
Oh, you're right.
where they can take in all of this different information, because building science is hard, right?
Yeah.
It is a lot of moving pieces. So how do we get them more information? I don't think it takes jobs away. I think it levels them up.
I agree.
It
I
does.
agree
It
100%. I think that the service tech of the immediate future is just going to have to be smarter and know how to use his tools, but there's no way we can't just send a warm body out. They're now actually going to have to be smarter, more skilled to be able to use these tools properly, in my opinion.
Perfect. Honest?
No, I think we have a flawed and tired system for training new technicians. I'm excited to see, even here at this show, that there's some booths that you see VR headsets at.
Yeah,
I think that's
Interplay
really
Learning. Interplay Learning is over there.
Oh, are they
and-
here?
Yeah, they're here.
Oh,
they're,
nice.
they're over there somewhere. We'll go walk over. But
Amazing.
basically, what they're implementing into this educational standpoint is the fact that they're using virtual reality. They're using online-based education. So if the tech is not comfortable in the field yet, they can put on a VR headset and they can actually fix a furnace from the office, their living room, wherever, and just get comfortable where the parts are, where to put your meter leads, where to check things. So when they get into the field, they're not so lost. They've already got this visual in their mind. There's more technology in education coming like that through the loop right now. But I mean, we're still afar up. But like what Aaron was saying, I remember when I was doing my apprenticeship and I went to school, they were teaching me about a controller that was about 30 years old that didn't even exist anymore in the field. And I think some of the schools need to get on board with some of the newer teachings, the newer methods, because what you get is a lot of people that have been in the industry for a very long time. They get stubborn, they get hard-nosed, and they have a way of doing things, and they don't want to stray from that, and they teach their apprentices this.
Yeah.
And
Yes.
then it's just this continuous trail of misinformation and nobody adapting or readapting to the new way of doing things.
Yeah,
They
we're
won't have a choice.
we're working with the National Research Council of Canada, and they've been very much a part of the development of Avx. And one of the things that they've been trying to do is get us into the community colleges, and it's amazing the lack of interest at some of the community colleges. It's shocking, and we're saying we'll give it away for free. We will set it up for you, just so you have it, because we'd like to see this being taught. And some are receptive, but some just don't seem to want to try something new.
Very cool.
New group of people coming into this trade, and I'll tell you, they respond to the digital stuff a lot better than the old school guys. What I really like about things like interplay learning is that someone can spend more time focusing on how something works versus how to make the tools work. And when you're new in this trade and you go to trade schools, I think everybody really miscalculates how hard it is to learn how to actually use the tools and piece the pieces together. And they're so focused on that, they don't focus on the larger picture, how things actually work together. That's why I really like the idea of interplay learning. I'd like to see more of that. I'd like to see that at our colleges. I know that Gary's been a supporter of it, and they've seen exceptional growth over the last couple of years.
Good.
Very cool. Awesome. So if that's it, then I think we can call this one.